Today we're going to look at programming or reprogramming an Icon controller. In its proprietary version, it's a TAC-20. What we'll first need to do is look and make sure we have all the correct components to do the job. And then we're going to look at the process using HyperTerminal to go into the actual controller and rewrite the program. So first, let's take a look and make sure we have everything we need. We have our laptop that we use to interface with the controller. It's equipped with HyperTerminal and with a serial port on the back. You have to have a serial port in order to plug into the controller. We have our power cord. If your battery in your laptop isn't very strong, you'll need to be able to plug in. We have our interface cables, and for simulation purposes today we have the motherboard, a 188E board out of an Icon controller. Now if you'll notice, this is one of the newer Icon controller boards, so it has a 9-pin port that you would need a 9-pin connector for. So you need a 9-pin serial port on your computer, as well as a 9-pin port to connect into the port on the board. If you had an older Icon controller, the 188E board would have a 25-pin connector, so you would need a cord that looks more like this in order to interface with that. One important note, if you are connecting to a 188E board that has a 25-pin port, make sure that you connect to the port that's on the board itself. There'll be a 25-pin port right here. Some of the older Icon controllers actually have a 25-pin port built into the frame, and that is a 485 port. As you can see, this port is labeled a 232. You always want to make sure you're plugging into the 232 port. If you plug into the 485 port, you could damage your equipment pretty badly. And I don't know why Thyssen would build an elevator and put two ports that are identical, so that one, if you plug into one, you program your elevator, and you plug into the other and you fry it. It only took them about 8 years to get rid of that. But thankfully they did. Just keep that in mind if you're working on an elevator that's older. So now that we know we have all of our components, let's get everything hooked up here and let's get going. Okay, that should do it. We're plugged into the wall. Our laptop is booting up. I'll go ahead and get rid of this cable. We'll be needing that. As you can see, while that's booting up, we have our 9-pin connector plugged into our serial port, good and tight. And we're going to log on to the computer. Okay, we can go ahead and hook into our controller, which, being a newer board, we'll hook here on the 9-pin 232 port. Now, we're ready to bring up HyperTerminal. So you'll need to find, probably under your accessories and communications banner, if it's not already readily available, the HyperTerminal software. Since we use it fairly regularly on this machine, it's in the recently used programs list. I'm just going to click on it there. Okay, once HyperTerminal pops up, you're going to see a new connection window. It's going to ask you to make a new connection. On this computer, we're just going to cancel that out. We don't want to make a new connection. We're going to go up to the top corner to the File menu. And we're going to pull down and open an existing connection. I have a connection already in there saved for Icon. So click on that. Now at this point, if you are plugged in to your elevator controller and you've opened HyperTerminal and you've established a connection with Icon, you will get a string of letters and numbers and gibberish right here at the top of your screen. Now, since we're just simulating a program, the board's not actually on. Obviously, it's not communicating with that board. However, if your controller was live, you would get a string of data right there, about 16 digits long. Okay, so the next step, once we have HyperTerminal open, would be to start the programming sequence. Now, as you can see, there's the reset button in the lower left-hand corner of the board, labeled RST, and UDL is upload download button. So what we would do is we're going to push both these buttons at the same time, and then we're going to release the RST button. And when we do that, we're going to look at the display. We're going to hold UDL and watch the display of the board until we see the word Z modem come up. When Z modem comes up, that means you're in the right mode. Now, this board doesn't have a display on it, it's just from the parts bin. But when Z modem comes up, that means you're ready to download your program. Now, prior to this, you should already have stored the new software in a file folder somewhere on your computer that's easily accessible. So, for instance, create a file folder under the C drive so that you can type in a string to get to the correct folder to find your software. So then it's as simple as clicking on Transfer and Send File, and then you have to tell the computer where the software is. So you would just come up here and you're going to type in C:/PWC6, that's my folder name, /. Now this part is important. For the file, they're DAT files, but Thyssen creates their DAT files with different names. There's 5 differently named DAT files, and they have a string of characters after the DAT version of the file, part of the file name. So we would need to type in star.dat star. That tells the computer that I want to download all of the files in that folder that contain the DAT file type. And then anything, it can be any file name as long as it's a .dat file, it'll send it to the board. And then when we click send, it should pop up and say sending 1 of 5, and then it'll cycle through all 5 files and install them onto the 188E board. Once it's complete, the elevator will reboot. You'll see the watchdog LED, which is down here by the RST button. You'll see the watchdog LED flicker out and come back on. It should come up in normal operation or inspection, whichever mode you left the controller on, and you should be ready to go. You will have to do a hoistway setup after you've reloaded your new software. And that concludes our training on how to reprogram a TAC-22 or an Icon controller.